Thank you for tuning into Blender Studio S. This is Somitsu. If you're looking for some cool looking text effects to try out in Geometry Nodes, you're in luck, because I will be going over how to make this text dissolving effect. When pulled off right, text will break apart into particles and vanish into thin air, leaving anyone watching in awe. Or well, that's just the idea. So, if you're interested in text animation or making nice looking effects in GeoNodes, thank you again for tuning in, and let's get into it. Alright, let's start off by hopping right into Geometry Nodes layout. A to select everything, X to delete, Shift A, add a new mesh plane. Numpad 7 and 5 to go into top orthographic view. Click on new, delete the group input, replace with string input. Type in something like test in here, pass it through strings to curve, and output. Alright, so today's effect is going to be dissolving effect. So what we want to do is the dissolving is going to take place from left to right. The text that has already been dissolved, we want to break it apart into tiny squares and let it fly off and disappear. Right? So that's what we want to do. So there are a couple things that we have to prepare, and the first thing is this mesh that breaks apart into tiny particles, right? It's not as easy as it looks. The reason for it is if I look at this result of fill curve, you can see that it's made out of various size triangles. So it's not easily made into these tiny squares that we want. Even if we set it to n-gon, it's not going to make a difference. So instead of using the result of this fill curve directly, what we want is to use a grid. With grid, we can control these vertices to make tiny squares, so that's what we're going to be using. So the first thing that we want to do is basically cover this text with grid, right? So I'm going to have a grid that's overlapping this text like so. So let's first off place this grid with the adequate size on top of this text. So what I'm going to do is realize instance, add a bounding box, and use these min max to measure the size and position, right? So what I'm going to do is vector mass. Let me get some real estate. Right, so I'm going to change it to subtract max from min, separate XYZ, plug in this X into grid size X, grid size Y, like so, and let's see it output. Okay. So right now we've made a size that is covering the text, but it's offsetted. So what I'm going to do is also duplicate the subtract, change it to add min with max, duplicate the add, change it to scale by 0.5. Add a transform geometry and plug the result of scale into translation, like so. Okay, so now we have a grid that is covering the text, like so. Okay, all right, now we want to start instancing points on the grid where it's intersecting the text. But in order to do so, we need to kind of determine how big of a square that we want. So I'm gonna use a value node to control the size or the length of the size of squares. So I'm gonna set it to 0.01 for now, which is essentially 1 centimeter long on each side of the square, right? I'm gonna calculate how many vertices I'm gonna need. So I'm gonna duplicate to subtract, change it to divide, and this result of subtract, I'm gonna divide it by the length of the side of squares. I'm gonna duplicate this, change it to add 1, duplicate the separate XYZ, pass it through, and plug these into vertices X and vertices Y. Now we get this grid with these pieces of 1 centimeter squares, like so. Okay. It's right now still a huge slab, so what I'm gonna need to do is instance on points, and I'm gonna instance yet another grid with size of this length. Vertices counts are gonna be 2, and plug it in like so. Okay. So now we have this 8,600 pieces of small squares, right? What I want to do now is to project this text onto these points, so we only get the squares on the places that we have the text. I'm gonna use a raycast node. Plugs a mesh into target geometry and plugs this is-hit result into selection, like so. Okay. I hope you can see it. So fill curve goes into raycast, raycast goes into selection. Okay. Right. Now we basically have two mesh of this text, which is this kind of pixelated version that comes out of instance on points, and this clean version, which is output of fill curve. Going back to what we want to do, right? So the dissolving is going to take place from left to right. So left to right, it's going to start dissolving. And say, for example, we've already dissolved to this point. We want to be using a clean mesh on the right side, but we will be using the pixelated mesh on the left side. So I'm just going to call the left side particle mesh. And the right side, I'm just going to call it base mesh. So this clean version is base mesh, and this pixelated version is going to be particle mesh. So depending on how far along we've come with dissolving, we want to be able to switch around the particle mesh part and the base mesh part. Okay. In order to do so, we will need to add another object. I'm going to add a bounding box. another object that kind of signifies how far the dissolving has taken place. Okay, so I'm also going to use a transform geometry after the bounding box, like so. And I'm going to shift around this X to basically signify how far along we're in the dissolving process. Okay, so if I'm right here, basically with this box, we've dissolved this left part, but the right part is still intact. Okay. All right, so like I said, we want to be able to switch between this base mesh and the particle mesh based on this position of this bounding box. Okay, so what I'm going to do is, starting on the base mesh side, I'm going to use a mesh boolean, change it from difference to intersect, using the result of fill curve and transform geometry. I'm gonna use a mesh boolean and output, right? So right now, any part that is intersecting, the base mesh that is intersecting with the control box is going to be outputted like this. Okay. Right. So done with the right side, but what about the left side? So the left side, what we want to do, we can use the mesh boolean, but instead I'm just going to use another raycast. So I'm going to duplicate this raycast, plug in the target transform geometry into target geometry. And what do I want to do? Okay, so any part that is basically not hitting this box, and also that is hitting the text, that's where we want to make the pixelated mesh up here. So I'm gonna use a mesh boolean. Oh, never mind, boolean mask. Set it to not. So the result of this raycast is gonna be a not. And also, I'm gonna AND it with result of this raycast. Okay. So result of text raycast and result of control box raycast. I'm gonna plug it in like so, and that's how we get the left side. Okay. So this is gonna be the particle mesh side, and this is gonna be the base mesh side. What I'm going to do is join geometry, the left side particle mesh and right side base mesh, and I'll put like so. Okay. I hope you can see that based on where the control box is, you can see the particle mesh is switching between, well, the mesh is switching between the particle mesh and the base mesh, right? Kind of like so. Okay, cool. I'm just going to clean up a little bit. Let's see. This part, I'm gonna call it control box. So we're controlling this box to determine where the mesh is gonna separate. And this part is going to be the base mesh. Okay. And this top part is going to be the particle mesh. Okay. Alright, so we've successfully separated these two mesh. Now let's add some movement to the particles. Okay, so what I'm going to do is, after the instance on points, I'm going to add a set position, and also a noise texture. Change it to 2D, add a vector mask, subtract, plug in the color to the top socket, subtract 0.5, and plug this vector into offset. The reason for subtracting 0.5 is this color value is only outputting between 0 and 1. So if I don't subtract, it's going to shift everything to the top right. So subtract to recenter it to 0. Also, right now everything is moving in X, Y, and Z direction. So I'm going to constrain the movement to XY plane by multiplying with 1, 1, and 0. So right now, as you can see, everything's constrained in XY plane. Okay. And what I want to do next is to, since we want dissolving to take place from left to right, if it's closer to the region or border between the clean mesh, the base mesh, and the particle mesh, depending on the distance from here, we want to make sure that effect gets stronger as it moves away, right? So what I'm going to do is add another vector mask, change it to scale, and what I want to do is get a distance from where the control box is. So what I need is a geometry proximity node. Plugs the result of control box into target, grabs the distance, and put it into scale, right? So now, if I add another mask node, change it to multiply, and change it to some value like 3, you can see that the further away the points are from the border region, it's gonna be affected by the noise a lot more. Okay. All right. So let's see. If I now move the control box around, we can see the dissolving taking place, except since the particles are still remaining on screen, it's kind of cluttering up this viewport a lot. So let's kind of make it disappear as it gets further away, right? So what I'm going to do is add a scale instance. Add a map range node. And using the result of this geometry proximity distance, I'm going to say from 0.1 meter to 1 meter, the scale is going to change from 1 to 0. So once it reaches 1 meter away, it's going to basically scale to 0 size, right? So now, if I change the position of this control box, you can see the particle gets smaller and smaller, and it's going to disappear to nothing, right? Okay, so I think we are ready to animate. So what I'm going to do is add a scene time and also a map range, and combine XYZ like so. Okay. I want the dissolving to take place between 1 second and 10 seconds. Oops. And I'm gonna shift the control box from left to right. Let's say 2 meters. Okay. All right, let's see it animate. Cool. So it is animating. If you want to flip the effect around, we can flip these values around, making it more of a constructing effect rather than dissolving effect. It's basically fusing together to become a text now. All right, I'm gonna switch it back. Cool. But I have to address one thing before we kind of finalize this. Say, for example, if I change this text into a more complicated text, something like this, right? And if I run the animation now, you can see this obvious FPS drop. It's like less than 10 FPS. So let's kind of fix this before we move on, right? So if I look into the timings, if you go to this drop down and get the timings overlay, you can see which process is taking how long, right? So the strings to curve is taking 0.1 millisecond. This fill curve is taking long, but nothing actually compares to this mesh boolean right here, which is taking 114 milliseconds. The reason for this is it's more intrinsic to Blender of how it does boolean mesh. But what I'm doing right here is basically taking boolean of this text mesh, fill curve mesh, and this control box, right? And as you can see, these two are both flat plane meshes, and they're basically on top of each other. Blender isn't really good at doing this. So what I can do is instead of booleaning two flat plane meshes, I'm gonna extrude this control box, right? So right now it's flat plane. I'm just gonna extrude it before I put it into mesh boolean. So it's gonna be a huge pillar like this. Okay. Now if I go back and run this animation, you can see the FPS is still constantly at 24, 25. And you can see that this mesh boolean now is only taking about less than 20 milliseconds. Okay. Whereas if I mute this guy, it's taking about 100 milliseconds. So as an optimization, please include this extrude mesh in here, so it doesn't really take that much time anymore. All right. I'm just gonna change this text to something more deserving. Dissolve. Okay, dissolve. And I'm gonna switch around some values. Maybe 4 is gonna be nice. All right. And let's see it render. Okay. I'm gonna add set material at the end. Set it to default. Using the shader editor, I'm gonna change the shader to emission. Change it to some yellowish, whitish color. Set the strength to 3. Go to World tab, change the color to black. Turn on bloom. Set the color management to standard. Turn off overlay. And let's see it render. Alright. Looks cool. I'm just gonna tweak the size of box. Maybe half size. Maybe that's cleaner. Alright. It's dissolving. It's pretty, isn't it? I think it's pretty. Okay. Alright, so let's go over what we just made. I'm gonna clean up a little bit. I'm just gonna... Okay, parent these. Okay. All right. So, let's take a look. Obviously, there's 3 parts to it. The particle mesh part, base mesh part, and the control box part. Right. Let's take a look from the left. So the usual strings to curve. Then we realize the first part of particle mesh is to make the grid. Then we instance on points and add movement to all the particles. Okay. Then we have the base mesh part, which is a clean text part, and control box that determines how far along we are with dissolving. All right. Awesome. This effect is pretty nice. I mean, visually, I like it a lot. I hope you guys enjoyed it. Thank you for watching the tutorial. As always with geometry nodes, you can pull off various looks with just tweaking few parameters. These two use the exact same setup, but right one has much smaller grid size. Left one gives off more of a virtual world kind of vibe, whereas right one looks more like smoke or haze. You can also have all text appear and disappear like this if you use scene time as a controller instead of bounding box. It is all up to you. So, thank you again for tuning in. This has been Blender Studio S.